Hello, this is to serve as a uh, brief overview of web security and related issues. It's actually modified, taking from some information from crypto class. It's the inferred CS155. So some of the issues I'm going to talk about include authentication, authorization, some forms of protecting against hacking, controlling access to critical data, controlling inbound versus outbound traffic, security versus accessibility trade-offs, security versus capability trade-offs, multi-tiered versus single-tiered solutions, and security versus expense trade-offs, and as well as brief discussion of overheads and complexity. So there are a number of solutions to help with security. Some are software, some are hardware based. There's a whole range of freeware, open source versus commercial products. Besides products, as part of the product or separately that you can implement are security protocols for communications. One of the things that we'll mention is cryptography, which is the science of encoding messages for security. And of course, there's all kinds of related technologies, stenography, which is hiding even the existence of a message, and so on. One of the issues that you might see in terms of web attacks is buffer overflow, but things are kind of getting better with regards to that. An example of sorry, hang on a second, let me turn that off. So an example of a very simple website architecture with very basic security would look like this, which is where you might have a firewall coming into the network that the company owns. You can have an intrusion detection system. We'll talk about that in another series of lectures and information. You might have an application firewall. Intrusion detection is meant to basically detect when people are trying to come illegally into your site, into your network, and there's many different kinds of intrusion detection systems. We'll talk about even the use of something called honeypots to help detect. Again, it'll be another lecture. Application firewalls tend to be very specific, hence the word application. So like a web application firewall will be looking at certain kinds of requests to determine if they're legal or not. And then what you're seeing here might be a load balancer where you're distributing, and that's just a very generic idea of distributing requests to maybe different web servers or different subsystems. And then there might be requests to data, databases, distributed data, and you would potentially be going through another firewall at that point where these requests are coming from your web servers, your applications back into the database layer. And you can have also other kinds of like specific application database application basically protocol detection systems too. So this is a simplistic example at a very high level. So some of the things that you might want to be checking for, like for example, when you're coming into your applications, is things like authorization. Do they have access? There's a lot of different kinds of attacks of web systems. Denial of service is where you see like a flooding, people just flooding with a bunch of requests. Lots of different kinds of attacks of specific web servers. So here we're talking about like Nginx, Apache, those kinds of web servers, and how they can be hijacked with different kinds of, and there's lots of different solutions out there for different kinds of attacks. The firewall we mentioned before, it really looks, there's different kinds of firewalls. Simple one is IP filtering, where it's looking at IP addresses coming in. You can limit portions of your network so that you can say only certain IP addresses, like let's say on campus, you wanted only on-campus IP addresses to access that particular system. Others are more oriented towards the application itself, and they're referred to as proxy servers or application servers. You've probably experienced that when you've logged into the library.csusba.edu. It has takes authentication to access, and you're basically going through a proxy server there. Web application firewalls look at things like if it's associated with a database, things like SQL injection, form field tampering, cookie poisoning, and there's, like I said, a ton of options out there available. Here's a few examples. We mentioned message information hiding. You want to do that through encryption. You want to utilize encryption in the creation of your websites, web systems. The most famous protocol for that is called SSL, which is Secure Socket Layer. And it basically uses encryption technology in order to set up a secure communication between the client and the server. And whenever you go to websites and you see HTTPS, you know in the URL, you know that you're utilizing SSL. They are utilizing SSL. So what is encryption? It's information hiding, and we talk about having some kind of algorithm where, for example, you type in the message hi there and it comes out with this m/0ku. So that might be one algorithm, and it's basically unreadable. Is the idea, ideally. And different encryption algorithms, of course, are going to give you different output. And then decryption is the reverse process. So taking that encrypted message and then recovering the original. Plain text is a little terminology, is clear readable text. Ciphertext is the unreadable, the encrypted text. And cipher is another term that people use to represent encryption and decryption. They're synonyms. So one of the technologies that is popular today uses the concept of keys. Like you have a key to unlock a door. And basically this is a secret piece of information that controls how the encryption algorithm works. And the first thing you need to know is that encryption is an active area of research. People are in computer science trying to always invent new and better encryption algorithms. And one of the things that happens if you look at and learn about encryption is that the keys get longer and longer and longer. And they may be taking different forms. But the basic idea is shown here. So again, we have our hi there message and the same encryption algorithm. And if you use Citizen Kane as your string for your key, you get this 10929 whatever output. But if you change that key just a little bit and you make it Citizen Kane O, you're going to get a totally different output. And if the key is hidden or private, then you're able to unencrypt the message. So there are basically two main techniques, the older being Symmetric Key Technology. And the idea is, Alice encrypts her message with a key and sends it to Bob, and Bob then is able to retrieve the message by unencrypting it with the key. The problem is Alice has to send the key to Bob, and how do you want to, that basically is not very secure. It's not a great way to do it. There's lots of problems with that. So you can have, how do you distribute a shared secret key? One of the newer, although it's been around for quite a while, ideas is asymmetric key cryptography that gets rid of this idea. And you'll hear a lecture or an interview with one of the professors who has a Turing Award for doing this kind of technology, and that'll be really interesting for you to hear. But the concept is you have not one key but two keys, a public key and a private key. And the public key is known to everyone, so John, Jane, Alice, Bob, whoever, they all know the public key. But the private or secret key is something that each person keeps to themselves. So let's say John wants to send a message to Jane. He uses Jane's public key, which everyone can know about, to encrypt the message. And the only way you can unencrypt it is for Jane to use her private key. So this is a way of her keeping that so she can only see those messages sent to her. All right, so this kind of just goes over what I just said. Again, John uses Jane's public key to encrypt it, and Jane uses her private key to unencrypt it. So obviously key distribution isn't a problem as long as Jane is able to keep her encryption key private. Authentication besides messages is something that you can use kind of like a digital signature. In fact, there are a number of online services in which you can pay a yearly fee to obtain a digital signature. And the signature could be for your person that you can utilize, but it could also be to basically certify software, particular software, or an agency. VeriSign is one of the companies involved in the past, but there's many others that are considered third-party, trusted, authorizing organizations that distribute these signatures and certificates. So this is just kind of showing again that whole process. So digital certificates, the certifying authority again is going to, if let's say Alice wants to get a certificate, she would have to register, prove who she is to, let's say, VeriSign, and they would give you one. SSL actually uses certificates. So whenever you do financial transactions today, you'll notice whenever you go to pay for something with Visa card, or if you're on your bank, you'll be using HTTPS in the URL. It says it's using secure web. And basically it's using SSL today. And so this is a picture of the idea of what's happening and how SSL works. And this is something that if you had your own web system and you were needing secure transactions, you could implement. You can get software to support SSL in a number of different languages. And there's a lot of different services out there too that you could pay for that do SSL cloud, as well as just services that would handle all the transactions for you securely. So here's the idea. Jane connects to John's server, and John's server returns a certificate. Maybe it's signed by VeriSign, whatever, plus something that's encrypted with John's private key. Jane can verify that the certificate is valid, and how that can happen is a number of different ways. These you could actually think of as John and Jane as programs. It doesn't actually have to be people, but if it is an actual person and you're using a web browser, let's say Chrome, Chrome has a number of default certificate authorities, like VeriSign, I believe, is one of them. But you can set that up. Otherwise, it'll, depending on your options in your browser, it'll pop up a message and say, do you trust this organization? And then you can say yes or no, and it will then become accepted. So sometimes if you've seen that message, that's what's happening. But that step is what we're talking about. The public key is used to decrypt the token, and John is authenticated. So most of that happens automatically for you. Potentially as a user, you might see, depending on your settings, do you trust this organization? What happens then is the browser makes a one-time session key. Okay, so this is how we're going to set up a time period in which we have secure communication specifically between Jane and John. Okay, so this is a session key, K, and encrypts it with John's public key and sends it to John. And at this point, that key that was created at that moment is unique for that time session between Jane, or her Chrome browser, let's say, and John, or really his web system. And at that point, you start sending transactions. Now, if you've ever been on a banking website, it'll time you out. And part of what will be happening in there is that that session time has elapsed. Maybe they'll give it 10 minutes, or they'll manage your inactivity, and then no longer do you have a valid symmetric key for you guys, for your browser and the bank, let's say, which is like Jane and John, to send secure communications over. So lots of attacks. We have a lecture kind of talking about that. So this again is a very brief overview. You want more information, there are classes that you can take discussing network security that will cover in detail things like encryption and networking protocols and things like that. We're not going to get into that level of detail here. Denial of service, DDoS, distributed denial of service. They can use a robot type program to launch, basically flood. Buffer overflow, sending huge amounts of data, that's another one. There's, very generic tips to avoid each of those. The denial of service, there are special software, basically that you can detect. Of course, if it's distributed, it's harder to detect compared to like coming from a single IP address. That's easy to prevent, but there is software out there for that. Buffer overflow, you want to be careful about how much data you receive, those kinds of things. Okay. So web application code, there's tons of reports, and we'll look out at some cases later of web attacks, but everything from, banking apps to shopping carts and all kinds of things. lots of apps don't really consider security, unfortunately, and certain languages might be more prone to attacks over others. But pretty much every language you can think of has had attacks, problems written in it. So some things like SQL injection, cross-site scripting, HTTP splitting, these are types of attacks that really result from inadequate validation of the user input, so allowing people to type into forms bad things that can cause problems on the back end when you don't actually parse the statements that have been sent. And we will have some lectures on SQL injection, some videos that I'll have you take a look at to look at that specifically. There's other issues like broken session management, trying to hijack the sessions, and so on. So here's basically an example of someone typing in, let's say, a URL, and this is the direct use of like user input. And so then it might actually try to invoke something called copy.php, and if that existed on there, it might copy data. And so this is an example of how it could be improperly used. So you're saying copy.php and then the name, and what if you specified this as a Unix machine, for example, it's running on a /rm star. So what it is going to do in that case is it would actually try to remove all the files. So huge problem. Redirecting, trying to redirect the browser to a particular URL can be a way of people doing phishing. Cross-site scripting, the user input is echoed into the HTML response. So here's an example. You might type in this search request, and maybe it responds with this output. And is there a way that you could exploit it? And the answer is that take a look at this. So consider this link. Okay, so what are we doing here? We're opening a window, and we're actually running this script to open a window and go to a particular website and pass some cookie information from the browser that you might not want to be passed. Obviously, phishing, you just saw an example of getting cookies off of it, depending on what you type in. So worse could be attacker can execute arbitrary scripts in a browser, control links on a page, can infect other users. There's a case of this. If you look up on the internet, myspace.com worm, you can read about an example of that. The users can post basically, this is the SAMI worm, HTML on their pages. So myspace.com, if those of you don't know, it was a precursor to Facebook. It's not that popular. I don't even know if it's around anymore, if you want to know the truth. It was for a number of years being used by musicians, interestingly enough, for promoting, but I really don't know where that's at now. But anyways, this is a famous worm. And so MySpace ensures HTML doesn't contain it contains nothing like this, but you can do JavaScript with CSS tags. And so you could hide it with this kind of message. And basically what happened is the SAMI worm created a JavaScript hacking using this. And basically anyone who adds Sammy as a friend, basically it just keeps going and going and going. You can take a look at them. All right, I'm going to skip over XSS bugs. This is a little bit about cookies. We mentioned cookies before. Cookies are things that web servers use, websites use to save information on a browser or a client. So like when you go back, it says hello Lynn, right? Or it fills in your login information. That's type of stuff is done with cookies. Ads are often served using cookies like browsing history. It might save information about your last purchase, and so when you go back to the site, it sends the cookies and then customizes the site for you. So you can turn off cookies in your browser. Most people don't even know about it or care about it. And there's been a number of, over time, bugs with cookies. Here's an example of maybe a seemingly silly thing to do with cookies, but it actually worked. In this particular case, trying to again change the values of cookies and guessing cookie names like shopping cart total and changing it from, let's say, 150 to 15 in order to buy something. And another example is hidden fields. People sometimes use in HTML. And these are actual real sites that had this particular issue. So people, these crooks basically ended up, instead of paying 150, bought something for $15. So encrypting cookies is storing is one thing with a security key, and having secure cookies is a way to help solve some of that problem. I'm going to kind of skim